Okay, you're welcome to Science Planet, and this is part 2 of another likely question for the chemistry Waec practical titration, which is coming up tomorrow. Okay, so here we have A is 0.1 mole per dm cube HCl, B is a solution of 8 gram per dm cube XHCO3. Okay, so here we are asked to put A into a burette and titrate it against 20 or 25 cm of B using methyl orange as indicator. Repeat to obtain crocodile titers. Tabulate your burette reading and determine the average volume used. The equation of the reaction is written there boldly. Then we have 3B. From your result and information, calculate the concentration of V in mole per dm cube, 2 concentration of V in gram per dm cube, 3 molar mass of B, 4 relative atomic mass of X. Then we have the atomic mass of each element there. So writing down our important parameters. So our concentration of HCl is 0.1 mole per dm cube as given to us in the equation. Then we have done our titration and our volume of HCl used is 25 cm cube. So that's what I want to use. I want to use 25 cm cube. Okay. When you convert it to give it dm cube. So but let's leave it as 25 cm cube first. Then the volume of our base, the one we pipeted with our pipette, is 25 cm cube. Okay, then the mass concentration of B as given in the equation is 8 gram per dm cube, and we have our balance equation as also given in the equation. So let's start up. So calculating our first question, which is concentration of B in mole per dm cube, we apply our titration formula CAVA Na over CBVB and B. Okay, so remember our Ca is the concentration of acid, that's our A. Then our Cb, concentration of base, so we are looking for Cb, so we have to make Cb subject of the formula. So making it subject of formula, inputting our parameters. Remember our Na and Nb is 1 because the mole ratios are 1. Looking at the equation, you see that they are 1:1, so our Na and Nb will be 1. So doing the calculation, you will be having a 0.1 mole per dm cube. 0.1 mole per dm cube should be the concentration of our B. So it's very clear. Just make it subject of formula, make your Cb subject of formula, and you're good to go. Okay, so number 2, they say we should calculate the concentration of V in gram per dm cube. So it has already been given to us already, which is 8.0 grams, so no need of calculating that. Then number 3, we are asked to calculate the molar mass of B, and you know our B is XHCO3. We don't know what X is, we don't know. So to calculate it, you use the our stoichiometry mass equation, which is mole equals to mass over molar mass. So make molar mass subject of formula. You have what is written here, which is molar mass over mass concentration over molar concentration. So remember our mass concentration is 8.0 gram per dm cube. That is what is given to us. Then our molar concentration is the one we calculated in the first one, which is 0.1. So divide 8.0 by 0.1, you have 80 gram per mole. So 18 gram per mole is our molar mass. So we are asked to calculate the relative atomic mass of X in XHCO3. So our formula will be the XHCO3 equals to the molar mass, which is 80 gram per mole. So calculate the molar mass of HCO3. Okay, so in calculating it, you know, remember your hydrogen is 1, carbon is 12, oxygen is 16, so multiply it by the 3 at the front, so you give it 48. So add everything up, it will give you 61. So it will now be X plus 61 equals to 80 grams. So collect like times, so 80 So if 61 go to meet 80, it will be minus. So it will now be 80 minus 61, which will give you 19. So x is equals to 19. Yeah, somebody might be saying, but x is not supposed to be 19. X is 23 because sodium is 23. It doesn't matter. It doesn't matter. Sodium, we got 19 because of the titer value we used. Okay, so Waec wouldn't mind if you get 19, 20, 21, 22, 23. What they will check is your procedure, your accurate procedure, the steps you use. They will mark it correctly. Okay, so it doesn't matter.